Hello, welcome back to my YouTube channel and good evening to one and all. Today we are going to talk about some basic reverse engineering, like what are the structure of that assembly program, how it is written, and how do we compile it, and exactly how we are going to make use of GDB in order to analyze a particular file so that the basic reverse engineering, like how exactly we do it, what are the steps using a tool, we are going to understand it today. Okay, so the very basic one is I constructed using gedit some test file in ASM language. ASM extension simply means assembly language, and this is a low level language. So this is the particular structure. Here section dot text in this particular one, what we do is we write all the instructions which are going to get executed by CPU, and we have to also, along with that providing of a structure, and we have to also declare start, like to in assembly language we have to provide each and every instruction to the system, that from the very beginning, like how it should start it, what are the things that the program should do, and how it is going to get exited. So everything, from step to step, we have to provide everything when we write any code in assembly language. So this is the structure. We have to mention a start, and in this particular one, we mention about what are the code that we have to, request the CPU to get executed. And we have to also provide exit command in order to exit the program successfully. And this section dot data which I have provided here, there are many other sections that are included into assembly language, but here I've just provided dot data where it is going to mention about global data, which means like this particular ASM language, this particular program, here we are just testing like how, like it is going to, just when I'm going to run a test file, it is going to get executed and we will get a print of hello, this particular word. Simple. I'll show you how. Okay, suppose this is the one. So this is the only word that is going to get printed before us. So this is the only thing that we are going to get as an output. And see the structure in that assembly language, it is comparatively long. If you are going to get make a comparison of it with some high level language or any other language in high level, then comparatively we have to write each and every step. So in that start, what we have to do is everything starts with RAX register. Whatever we have to write or we have to print, like in this particular program, we are not taking any input from the user, and we are just providing an output from our end, hello. So it means the program is reading something. Okay, and that reading has already been provided in data section. So the first thing that we have to do is we have to provide some read values, like we have to test it using man, and 2 is for system call, then read. This is what we exactly do. Okay, when we have to ask a program to read, means to provide some output directly without even asking for any input from the user end, we have to type man. 2 means it's about the system call, and we have to exactly mention about that particular word of syscall. Like here in this particular program, we are talking about read. Read means that hello word is directly going to get executed from this program. We are not taking any user input. So in this read text, we have to provide further 3 inputs, which is talking about some integer, some buffer in the sense like some this particular, what to say, the word which has been, where it has been stored, that particular variable it is asking about, and the length of that particular variable, particular word which we are going to provide as an output. Okay, so 3 things we have to mention in read command. Okay, so for that what we have is in that, yeah, I mean, we are reading, but we are providing a writing command from our end. So specifically what we're going to do is we have to first go to that user, include this this particular path. Here we have lots of syscall syscall commands which we have to follow. Like from this particular program, something is being read by the other person who is going to see the output, and we are writing the input from our end. So for writing, we have taken the syscall digit 1 which we have stored in RAX, and after that we have multiple registers that are being followed by after RAX, and after RAX we have RDI, then we have RSI and RDX, and so on. We have multiple registered. So the first register which we have consumed is RAX. After that, as we did see that this read command, it follows 3 other characters. Okay, so what we have to do is we have to provide it over here. So we are, whatever register we have after RAX, we are going to provide some value in that. And this RSI is also there as the word hello. What we have did is we have provided an integer type db and that particular word, and then we have stored it in a variable hello. So we have provided it over here. Now what we have done is after this, the other variable, the other register which is followed after RSI is RDX. In that we have placed the exact count length of this particular word. We could have typed it like 1 2 3 4 5 over here, but what we did is we chose a standard way of writing the exact letter of that word. Okay, so we have placed it into a variable of this name, and this is the command exactly how we do it. $signs means it is going to take the whole of the sentence, and from that it's going to minus the length of this one. It is going to provide the hello means this particular word. Okay, so it is going to somehow reduce the exact and get evaluated on the basis of this particular command, and it's going to provide the exact length of that particular word which is being placed over here in this particular variable. And after that we have to write syscall. Syscall, it exactly completes the whole of the system. Since we are not using some other libraries of assembly language like util, I think util is also some utilities. It's going to provide you some other functionalities as well, but since we are reading about some basic assembly language, so I've just used syscall over here. That is something different we are going to talk about in some other videos. Okay, so after that we have to always provide, whenever we start any instruction, by the end of that we have to write this particular word syscall. Okay, now the execution of this particular word hello, it has been done, and as we have already stored it and we have provided it as a variable over here, we have written it. Now the program, we want it to get executed properly without any interference. So what we have done is we have similarly we have also provided syscall for that exit command. So this is the particular exactly the instructions that we have to follow for exit. I can also show you over here, like since we used man 2 is for syscall, for exit command we are going to follow what are the instructions that we have to see. Okay, for exit we have just one variable, we have to provide one variable, and it could be of any digit, we don't even care about that. Okay, and this is the value that we have to provide over here, and what are the digit of syscall in for exit. We have to look over here, I don't know exactly, yeah, exit. As you can see, syscall, the digit for syscall is 60, so we are going to mention 60 over here. and as we did see, the variable that is going to accept is only one variable, which is of integer type. So we are going to place anything. I have written 0. We can also take anything like 22, so it does not matter. Okay, I'll take this one, and we have to, by the end of that, we have to write syscall. So this is the way a basic program is written. And initially we have to write global, and whatever the start of that program, the starting instruction has a name, like we have placed a name underscore start. You can also place any other name, but then you have to make some changes to this particular uh, standard parameters that the global follows. Okay, so usually the standard word is underscore start. That is what I have also followed over here, and you should also follow it. And if you want to make some changes in that, like underscore main and some other things, then you have to follow the changes accordingly over here as well. So as I've also mentioned underscore start, I'm just going to put global underscore start. And once, I mean, this is written in order to make the system understand like from where the execution of that instruction should start. Okay, so as we want to start our function to get executed from this function, so we are going to start from here. Okay, that is why we have placed it, and we want to exit it using this one, so this is how we have placed it. Okay, now what we have to do is we have to compile it. Okay, this is the basic structure that I've written, but I'm going to do it again for you people. It's a library for compiling of that assembly language. -f is for the file, I mean, in which I want to get it compiled. So as it is Linux, so elf file is there and 64-bit is there, and the name of that assembly file is this one, and the output I want it to be written in .o. Okay, here we have mentioned .o, which means it is still a object file, means it is not a file that can be directly executed. After it becomes an object file, we have to also link some additional files to this object file so that the resultant file can be executed by the command line. I'm going to show you over here. It's done, and we can see that we have, okay, we have a test file too. Okay, now we have to link it and this is the name of that final file which we are going to execute. So here you can see test2 is the final output of the file which we have to execute. So normally how we launch a particular file in that a particular file or any script in this command line, we are going to follow the same thing. So we are doing that, and it's simply going to present hello. This is the final execution. I mean, the motive of this particular file got executed properly without any issues. And I did mention you that you have to keep on looking this sys file definitions, that what are the functions that we have to use within a particular assembly language, like what are the instructions we have to follow, and along with that the digit of the instructions are important, and along with that we have to keep on looking at the manual. Like man2 is a digit of symbolism for syscall, and whatever instructions you want to read, I mean you want to get information about, like read you can choose, or write you can choose, or exit you can choose, anything is there. We are going to see right, as we're also talking about right. So it does have three things that we mentioned. Okay, simply that we already included over here with RDI and RSI. It was talking about the constant void, I mean some variable, and the size of that particular one that we included. Done. Now I am going to use GDB in order to understand the execution of some CrackMes. Whenever we do reverse engineering on any file or the basic file which is being utilized for reverse engineering, it is generally called as CrackMe. So I have downloaded some CrackMes from GitHub repositories and I'm going to utilize that. First we are going to see what exactly, I'm going to just analyze this one, CrackMe, and we are going to see what are the function that is exactly being executed in this particular script. Okay, enter password, it is asking for password, and as we don't know about the correct password, so maybe it is going to just put some prompt before us like wrong password. Yeah, exactly, wrong password, which means if you are going to provide some right password, it is definitely going to provide us the prompt like correct password. So we are going to do reverse engineering in this. We are going to type GDB, then CrackMe. Okay. Okay, from here we are going to run it so that we see how exactly the execution is being taking place. Okay, yeah, wrong password simply, and we can see there has been no error. This system, the process exited normally. There was no issue with this CrackMe, this particular script. Okay. So now we are going to see info functions. These are the commands and it comes with practice. Even I sometimes don't remember it. I just have to keep on consulting with my notes. Okay, it is going to definitely loads multiple other functions as well along with that CrackMe. So it's of no use. We can quit it. Okay, now again I'm going to, first I have to quit it. Okay, now again I'm going to GDB on that CrackMe file. Okay, again I'm going to see the influence functions. Now this time I am going to see the exact structure of this CrackMe, because earlier for the very first time when a program is executed, other functions along with that particular program is also executed and we see a lot of functions. But for the second time when we load any program for reverse engineering, we see the exact structure. Like here we are seeing that main function and other functions embedded with, and other dependencies are over here are also mentioned along with that memory addresses. So this is very cool, because sometimes what happens is some instructions does not have any proper name or does not have any name. So in order to navigate to that particular memory point, we make use of memory addresses. So this time, okay, usually what we do is we start initializing, we start reverse engineering using the main function. So here also we are going to do the same thing. We will type disassembly main. Okay, we are going to disassemble. Okay, here you can see it is in the other form of assembly. Assembly is exactly in two definitions, two programming structures like Intel and AT&T. And this is the structure of AT&T. So it becomes really tricky for people who have recently started the reverse engineering. So we as a naive people who have recently started reverse engineering, we will try to analyze the structure in Intel. So what I'm going to do is I'm going to set the disassembly flavor into Intel. Okay, it has been set. Now again I'm going to disassemble it and we'll look at, yeah, this is the structure now which we are capable of understanding it. Okay, so now once we have a program in this particular format, what we're going to do is our important point of focus should be calls, number of calls, and should understand all the structures above and below it. Then we are going to look near to the comparison instructions and jump instructions. These are the important things we should look upon. Here what we're going to do is, okay, this put command is definitely used to provide some like how it got prompted hello. In the same way, some messages is also getting prompted. Okay, then we have some instructions after that. So definitely it could be like enter the password that we recently see. If you're going to run it, obviously we are going to understand it. Okay, is the structure, move is there, this is a destination, and this is the source. From here to here, all the addresses, all the values are get stored. He stores the memory addresses from some other registries. And move, then we have called scanf, means it is going to try to take some input. And obviously we did provide some input, like when we were asked to provide input after enter the password, we typed some random numbers, and since we did not know any specific ones, like what exactly the correct answer was, so we provided it. And scanf simply means the input is being asked from the user end. Okay, then here some comparison of like how the wrong password prompt was put before us. Obviously the instruction, the program could have somewhere compared our input with the input of correct password, and since we did not know the proper password, and when it was compared with the system password, I mean with the password that the program already had, obviously it got jumped. JNE means jump if not equal to. When the password was not equal to what was placed inside the program, it got jumped to which instruction? 11CD. Okay, from here to it got jumped. Okay, when it was not, okay, I got it. When it was not, when it was compared and it was not equal, it got jumped to over here, which means we have to put a breakpoint over here, or we can also put over here, so that after that we can type next instruction, and we are going to see how exactly the jump is taking place. And we are also going to see the exact password which is present over here in this format, so that we get the exact answer. Okay, now what we are going to do is we are going to provide breakpoint. We are going to use asterisk before every memory addresses. In GDB we have to provide asterisk. What is the jump instruction? This is the instruction from where once the breakpoint is reached over here, the breakpoint will follow all the instructions from here. Okay, we are going to provide the memory address. Okay, all the instructions will be executed before this memory addresses, and the breakpoint is going to help us analyze all the instructions after this memory address. Okay, we have set the breakpoint. Now we have to use disassemble main. Okay. Okay, just let me check once. Why is it not showing? Okay, let me try again. Okay, is also set at PC. Okay, I got it. Now what we have to do is we have to run the command. So it is going to, okay, yeah. Since we placed the breakpoint at this particular memory address, which means all the instructions above this one is going to get executed, and from here onwards we are going to keep on analyzing it. This is the main purpose of breakpoint. Like from here, by one step after the other, by step we are going to analyze each and every instructions of this particular program. Okay, see, before comparison we had some puts, which means some message was prompted before us, which is enter password. Scanf, which means it is going to definitely ask us for some input, and as we don't know about the password, so we are going to type anything. Obviously now the breakpoint has exactly reached to the comparison memory address. Okay, now we are going to again disassemble. We have to keep on disassembling it so that we see where the instruction have exactly reached. Okay, now from here it is going to execute each steps. Okay, then there is also one command, print, which can help us. First of all, we have to see info registers, like what are the things which are stored in registers. Oh, sorry, typo mistake. Okay, yeah, exactly. As you can see, we did see that in the comparison instruction. Where is it? We have some hexadecimal letters where, I mean, the value which is placed is in this form 539, which is comparatively quite different from, I mean, it's a lot different from what we have placed, which means we do know the registries are storing this and the value is not correct. Now we have to move forward and we have to see what was the exactly the number, I mean the password. Okay, exactly. See, the password is 1337. Okay, now what we are going to do is we are going to keep on running and see what exactly happens. Since we put the wrong password before, as we did not know before the comparison memory address was struck, we do not know the exact password, and we had already placed 1 2 3 4 5. Now we are going to see how exactly the program is going to get executed. Okay, we are going to again see disassembler. Like again, this time it is going to compare the value we had placed 1 2 3 4 5. It is going to compare it with 0 5, I mean 539, which is 1337. Obviously it is going to jump from here to this particular one, 11 CD. Okay, we are going to confirm that. Disassemble again. Yeah, obviously it got jumped over here. Now what we have to do is we have to put the right letter. Okay, again I'm going to see. Yes. Okay. Enter the password 1337. This time we are going to see it is going to get compared. Okay. Now we are going to see disassemble main. We are again at comparison and we are going to see whether the password which we have provided is equal to 0 cross 539 or not. If the comparison is correct, this time what is going to happen is it is not going to take the jump and it is going to print whatever the exact message which we usually lack because we did not know the correct password. Here this time, after the correct password is compared and it is justified, it's going to print these two proper instructions. Okay, now we are going to see. Okay, again disassemble. Okay, exactly. You can see jump if not. happened? Wait. Why am I keep doing this? Okay, we have to execute it. Fine, no issues. I'll keep on executing it till the end. Okay. Okay, there is no point in doing it. I have to again start GDB and then do it. Okay. CrackMe. Okay, from here, run it. Okay, type the correct password 1337 and we are going to see what exactly it is going to provide us as an output. It is the correct password. So that was all for the basic reverse engineering. I hope you liked the video. If you want any other video based specifically for any other things dedicated to cybersecurity, please provide that particular, your request in that comment box. Please do write it. And if you like it, like this particular video or related ones or whatever I've placed over in my YouTube channel, please do see that, and please like and subscribe as well. And more above that, if you want any other particular dedicated videos in the domain of vulnerability assessment, network security, malware analysis, threat hunting, threat intel, or anything into the domain of cybersecurity, please write it down in the comment box so that I can read it and I can make more videos dedicatedly on that. I can do that. Okay. Thanks for your time. Take care. Until then, I'm going to provide some new videos after this.